Our lesson today is motion. So, in this lesson, we'll talk about the motion and the description and the explanation. Measuring the motion, two fundamental components, change in position, change in time. So, when the object changes its position according to the time pass, so the object moves. But when this object doesn't change its position according to the time pass, so this object at rest, or you can say it is constant. Four important combination of length and time. 1. Speed. 2. Velocity. 3. Acceleration. 4. Momentum. What about the speed? So it's a change in the position with respect to time, or you can say it's a change in the distance by time pass. When the distance is changed by time, so you will find, you can say this is the definition of the speed. Speed can be only defined by using magnitude only without direction. For example, when I talk about this car, or just I say this car moves by 30 km per hour. So I give you the magnitude only. So it is a speed. But when I add the direction with the magnitude, I talk about the velocity. So when I say this car moved by 30 km per hour in east direction or west direction, I talk about the velocity in this time. Measuring units, kilometer per hour or meter per second. These are the famous measuring unit for the speed. Kilometer per hour or meter per second. Also here is a rule. Just if you want to calculate the speed, you have to use this rule. Speed equal distance by divided by time. So if I want to calculate the distance, you have to make multiplication, speed times time. And if you want to calculate the time, you have to make also the distance divided by speed, just to calculate the distance. And take care, the measured unit of the speed is meter per second or kilometer per hour, and the distance kilometer or meter, and the time hour or second. Also here, you will find this small dash above V, so it's a change into average speed. When I just write V dash, that means that is average speed. So the average speed equal distance by time also. Velocity. Describe speed, how fast is it going, and the direction, where is it going. You should mention the magnitude and the direction as I told you. Here, you will find, when I talk about, yes, this car just move 30 km per hour in east direction. Now I talk about the velocity. And what about the direction here and the direction here? The same direction, but the magnitude is different. So here it's 30 km per hour and here's 60 km per hour. So the magnitude is different. Now also the velocity different, because just they are different in the magnitude. But what about this car and this car? So you will see the magnitude is the same, similar in magnitude. But what about the direction here? Northwest and here east. So it's different in direction. Now they are similar in the magnitude, but they are different in direction. So also they are different in velocity. Acceleration, rate at which motion change over time, or also here you can say it is a rate at speed change over time. So the speed can change and the direction can change. Both speed and the direction can change. Now we have rule for the acceleration. Change in the velocity by time elapsed. Also, you can say delta V divided by T. So delta, this is small triangle, that means delta. That means the rate of change. The rate of change of velocity divided by time. What's the meaning of the rate of change or delta V? That means that the final speed minus initial speed, or V2 minus V1. So here is the rule: acceleration equal final speed minus initial speed divided by time, or final velocity minus initial velocity divided by time. If I talk about the direction, I say velocity, but when I just there is no direction, you can say speed. Example: if a car changes velocity from 50 km per hour to 80 km per hour in 5 seconds, then take care here. Here the measuring unit kilometer per hour, and here kilometer per hour, but take care the time by second. So you have change. Acceleration equal, so you know, final velocity minus initial velocity divided by time. So it's become 80 km per hour minus 50 km per hour divided by 5 seconds. So it's become 5 km per hour. But when you divided the time, so you'll find divided by second. Usually convert kilometer per hour to meter per second to keep units the same, because I told you here kilometer per hour and here second. So you can't use this rule without change the units. So you have to change kilometer per hour to meter per second. Then get 1.4 meter per second by divided by second, or 1.4 meter per second square. Represented mathematically, this relationship is acceleration equal final velocity minus the initial velocity divided by this slash mean divided by time. And the measuring unit is meter per second square or kilometer per hour square. Now I'll talk about another definition is momentum. Momentum is a product of mass multiplied by velocity. When you make multiplication mass times velocity, you calculate the momentum. Measuring unit is kilogram meter per second or gram meter per second. When you use the mass by kilogram, you can use the mass by gram. So the momentum equal mass times velocity. Here, this astronaut just the mass 60 kilogram and the velocity 0.750 meter per second. So when I want to calculate the momentum, this is a rule: momentum equal mass times velocity. So it's 60 times 0.750. The result here 45 kilogram meter per second. And also here, when you just calculate the mass of this object, satellite, so 120 kilogram and the velocity 0.375 meter per second, and the momentum, when you want to calculate the momentum, you make mass times velocity. So 120 kilogram times 0.375 meter per second. Here you will find the momentum 45 kilogram meter per second. Kilogram meter per second, this is a measured unit of momentum. Thank you and goodbye.